This is a computer. Everything on this little chip and on this little device here can run a television, it can run a computer, it can run a webcam, it can run a cell phone. It's about everything on here. So what it has, there's a USB port right here to get power. There's another little spot to get power. And then you can buy little pieces and you can just plug them in on these tiny little inserts here. You could plug in a fan, you could plug in a light sensor, you could plug in light bulbs, all kinds of different pieces. And this one simple thing called an Arduino, this one's actually about 4 years old, so they make them even smaller now. They're about this big. Can run all kinds of different activities. And I'm putting this up because this is the type of thing that makerspaces now are using pretty frequently. So I'm going to start one on this side. You could just take a look at it and pass it around. And then this is an even smaller version of it. So this is a micro Arduino. And with this one already has a little light associated with it. And you plug these into computers, you write your code on the computer, and then this makes different commands to do different pieces, to a light bulb or to a keyboard or to anything else. And these tiny little things can be created and used in makerspaces. I'll start one over here and you can pass these around. See there's a little battery on it. So what are makerspaces now that we're talking about them? So makerspaces are just literally a space. It's a compound word. Maker and spaces. We slash this here. On one hand, we have makers. Who are makers or what are makers? All of us. All of us make things. Everybody makes something, whether it's coloring when you're young, or making a paper doll, or building a garden. You're making something. Building a PowerPoint, you're making. And then the word spaces really means just making a space for makers, plural, lots of people to get together in a space to do this together. So this actually goes back historically for people that weave, right? A lot of people don't weave by themselves. If they're weaving a basket, you sit with several people and weave. If you're making a quilt, you quilt together. You sew together in a circle. Several people do this together. That's a makerspace. It's people that are making in the same space. All kinds of things happen, right, with makerspaces. The change that's happening is we're trying to move these makerspaces into the public library or the school library. So we're trying to take these spaces of creation and put them into the library for several reasons. So these are the types of tools and technologies you'll see right now in makerspaces. So as you saw, this is an Arduino that's being passed around, that one piece. You'll see how these little wires are being plugged into the different circuits, and this is connected to another board. And that can make something like where you could hook up bananas into that little machine, and you can use this like a piano, because each one of those ends up being coded to make a certain sound through that Arduino. And you can see how the keyboard on the screen lines up to the bananas, and you can actually touch bananas to play a keyboard. Right, and you're using some of the electrical currency inside of because these can transfer currency, because it's matter. So you're using those to actually be able to make things. You can mix technology, mix with real things, right? I say real because technology, it's not really real. The real is the earth. Real is the sky. Real is the dirt. These are things that are real. Fruit, that's real. So we can use these pieces together to make new things. So these are the other types of tools that you see frequently in makerspaces now. These are soldering kits. So the reason you want a soldering kit and a soldering iron with little stations to charge them in a case if a student wants to check it out and take it home, or if they want to sit around the library, is because that little circuit board that's going around, if you want to use it to build, let's say, a security system. So you can plug in a webcam to that, and then you can put a light sensor connected to it too. And anytime that it senses light, the camera turns on. And by doing that, you're going to need to actually solder the little pieces together onto that little machine. So little things like soldering become really important in a makerspace because you can teach people how to connect different types of electricity, different types of current, and make them permanent. So soldering stations are something that you see pretty frequently in a makerspace. Other types of things, power tools. Why would power tools belong in a library? Saws, hammers, drills. That's because we want to make stuff, right? We want to not just read about something, but we want to take a book that we read about and then try to make whatever we read about. if it's a book about a car or a book about a wagon or a book about a well. The next step after you talk about the characters and you talk about the plot lines, talk about the vocabulary, the next step is to build something from the book. Take the set and try to make it. And you can use these tools, and it's important for students to learn how to use tools and to learn how to make things. Because it's not just learning about what's in their head and what's in the book, but it's the practical, concrete skills that they have. Does anybody here build? Has anybody built anything ever? See a few hands going up. No one's made anything. None of you have ever made anything. Come on, I don't believe you. I don't believe you. No one's ever made anything in your entire life. You've never made anything. Around a bunch of, what did last night? A bunch of thieves in this room. You don't make, you steal. I'm kidding. We all make things, right? We know this. So it's an important piece to have, especially as children get more and more attached to technology. It's good to use their hands. It's good to have the brain muscle and your hand muscle working together so that your body's in unison with things. Other pieces are sewing stations. So sewing, a lot of people say technology, how's sewing technology? Well, sewing is technology. It's making, you're creating. So these become some of the most popular stations in libraries, particularly school libraries. In my college, the sewing station is the most used piece inside of the makerspace. And it's because the college kids they bring in their denim, their jeans, and they write something, they make a graphic on Photoshop, and then they can program it onto the sewing machine, and the sewing machine will type whatever they want and embroider it all the way down their jeans or embroider their jackets. So they customize all their clothing with these sewing machines by using graphics on the computer. So those become very popular. And there's a whole library of things that you can download to make embroidery. You can make patches, you can make all kinds of stuff with these sewing stations. So those are important too, as is hand sewing, sewing by hand, cross stitch, everything. Other ones, these are what we hear a lot about, 3D printing stations. I'm not sure why these graphics aren't coming up. Have you all seen 3D printers? I see a few of them. So the 3D printer, it uses this plastic filament. And the plastic filament goes into this machine, and it builds things layer by layer, little layer by layer by layer by layer by layer. And it can make anything that you program into a computer. So you can make little miniature houses, you can make toys, you can make really anything. It's unlimited to your imagination of what you can build. Unfortunately, it takes a long time to print these. It could take up to hours to make something. But it is possible to make, and it's really great for prototyping. If you want to make a prototype, particularly for people that want to be entrepreneurs and they have a new product in mind, instead of making it out of metal or going out to a metal shop to have to build it, they can make it out of plastic with this printer. And they can have something in their hand when they talk about their business idea or when they talk about something. Another thing that people use these for is building characters from books. They'll design it in Photoshop, which is digital literacy and visual literacy. So they'll make it there, and they actually print it, and you move into the 3D modeling, which is another important skill for students to have, especially as we start moving into more and more digital spaces. Another popular thing is called laser cutting. Laser cutting is fascinating. So it uses the same type of thing where you program your computer, you make a graphic on your computer, and then it uses a laser beam to actually cut your materials. So you can cut wood, you can cut plastic, you can cut metal, any of these pieces. So you could design something like this on your computer, plug it into the machine, and that laser will actually cut all of this. This was once a solid piece of plastic. And it cut holes and cut this entire pattern based on the graphic that they made in the computer. Now imagine how much time that saves for a craftsman to make something like this by hand versus the machine just burning it, going through and burning and burning. And what's great with the burning is it can cut in different dimensions. So if you want to just have a thick piece of wood, you can cut all the way through it and make something like that. Or you could just burn the wood and you can draw pictures on it by using the burning to actually make a wood burning on top of the print. Because based on how hot you want the laser to be, that's how far it'll cut. So you can do that as well. I'll show you some examples. So here's some projects that students are really happy about that they've made. So this is one where they've made a prototype of a little stylus, a little pin, and another piece to hook up to a cell phone. And those are his idea for a new type of device, a new type of cell phone. And instead of having to go to a company to make it, he used a 3D printer to make these initial pieces. This is somebody soldering some art, making these pieces and just soldering little pieces of metal together. This is a person typing in, initially started with that little computer that's going around, the Arduino. They hooked wheels up to it and made a little car, and they're programming for how it can work, so it can roll around and be something else. This is an example of doing pottery, but doing pottery mathematically. So instead of using your hands and a wheel, they start making these little bases, and then they put the ceramics over these bases to come up with their shapes and their forms before going into the ovens. This is it's really tiny, but it's a 3D burnt little toolbox. So that opens in different pieces because you can make puzzles, you can make all kinds of wood. And this is an example of using the 3D modeling in order to build something out of the 3D printing. So what's making makers they like to create things by hand. They learn from other people. Just think about any time you've created something. A lot of making comes socially. We socially learn. We watch usually our parents. Your parents teach you how to sew. Your parents teach you how to weave. Your parents teach you how to build with wood. And you watch each other and you learn. You're also following the steps of engineering. So you're learning how to think like an engineer every time that you make something, every time that you build something, because you're following steps, you're learning by trial and error, and you're building a constant database of problem solving inside of your head. Because every time you learn, you may fail, but you learn a new trick, and then you try it again. And you just keep building and building and building on what you're making. And when you put a group of people together, we can start leaning over our shoulders and we can see someone that's about to make a mistake and give them a hand and say, hey, don't put those two together, it's gonna fall apart, try it this way. The same way we were doing with Scratch, where some of you knew how to use it already, and you would lean over and help your neighbor. Or that creates a making culture where we're all making things, and that's what we wanna bring into libraries. Another good part about making is we're encouraging real world problem solving. We want to give students a problem to solve that's real, that's concrete, something they see around them. And another important part is it makes you consider that there's lots of ways to solve a question. There's not just one correct answer. And I think a lot of times in schools we get caught down with there's one correct answer because we test. In a test you can only usually get one answer one way. And it's a good way to learn, it's a good way to think, but the world doesn't work that way. We know that there's a million ways to solve a problem. There's a lot of different ways to solve it. And that's what innovation is. That's how you innovate, is you think of a new way to solve a problem. So we want to encourage that within our students. We want to encourage them to think that, yes, you need to follow instructions, and yes, you need to follow a set guide of rules, but we need to make space for them to also try something different, because that's where innovation comes from. It's when you try something different. Also using your imagination. And to know I think this is one of the big keys, to keep trying when things don't go as planned. There's no such thing as failure. Right? If something doesn't go right, it just means it didn't go right that time, but you keep going and you keep trying and you keep trying. Failure is a positive. Right? If something doesn't work, it means you're learning. Because if it's easy to do, everybody will do it. So we want to think about the design process in general. The design process, I have it in quotes because there's a certain process that we should be following. It's sometimes called the design cycle, the design spiral, the design compass. It could be called computational thinking in a way, because that's a type of, we had someone earlier bring up design thinking earlier with computational thinking. They're all using basically the same type of approach, an orderly way of doing things, an orderly way of problem solving, a series of steps that come up with a solution. So the design process, we want to think of it, there's 4 big steps, but it's cyclical and it's iterative, right? Which means that in the beginning you may define a problem, and then you want to brainstorm a plan, and you want to do this as a group, and we do that together. Then maybe you build a prototype, you build a sample of how something's going to work, and then you test it, and then it ends. Or if it's iterative, maybe you define a problem, you brainstorm it, you build a prototype, and your prototype isn't very good, so you go right back to brainstorming, and you start thinking again. Or maybe you build a prototype and you actually define your problem better. Because maybe you tried something, you're like, actually, that's not the problem. I think what the real problem is, and you singled up on your problem. And we can all think of examples in our lives where that's happened before. You try to solve a problem and you actually redefine the actual problem. You say, wait a minute, that's not the problem. So this idea of iteration, where you keep trying over and over and over. And when you're designing, you know that you may get all the way up to the testing phase, and that may take you right back to the beginning. Or you may get here and it may take you right back to the beginning, but that's part of the process, right? Failure is part of the process, and we keep trying and trying. What's important when you start teaching your students to do this, and this idea of making, is to prompt them. So we don't just tell them to make something and walk away. We always want to ask questions. So if they make something, you want to say, how does that work? And have them explain it to you. So you're talking them through it. How does it work? And get them to explain. The next one, does it work the way you expected? And this actually works for any project management plan that you have, right? You could say, does it work as expected? The next one, how can you make it better? Or who is it for? How could they use it? And these questions, while they're here for making, these are for life. This could work for any job that you ever do. The idea of when you're coming up with a problem, how does it work? Does it work the way you expected? Right? This is always going to help you debrief any project that you've ever worked on. How can you make it better? I use a very similar thing with every time I do a workshop. I go back to these questions. How did it work? How can I make it better? Did it go as the way I expected? And you want to encourage your students to keep trying while they're making things. So this is an active process for you as the facilitator. When you have your students making, you want to facilitate. Help them break down difficult tasks into smaller parts. Right? That's been a theme of the last several workshops that we've had. Look for smaller parts. How can we make a big problem smaller? Complement their efforts and remind them of the past success. So you can say, you're doing a really good job. I know you're frustrated right now, but remember the last project you worked on, you were also frustrated. And getting frustrated is part of work, right? That's why it's called work and it's not called play, right? Play is fun, work is hard. And just reminding them of that and to learn off of that. And also to take a break sometimes. Because we've all been frustrated where you can't figure out a problem and you can sit there for hours, or you can just walk away, take a walk, go eat lunch, come back, fresh mind, and then you can solve your problem. Sometimes you just have to get away, and that's an important thing to start teaching the students young, because we don't want them to stress out. We don't want them to, get all up inside of their heads. So there's 5 making prompts that I like to use for students. You can make it. You can ask students to make something. You can ask students to test something. You can ask students to imagine something. You can ask them to improve something, or you can ask them to fix something. And each one of these is a little bit different. Each one of these is a little bit different when you walk through them. So the first one, make something. Let's say I gave you a paper box. And we could say, what can you make out of a paper box, a piece of paper, maybe some tape and a pair of scissors? What can you make out of that? And just think about it. What can you make? And then you want them to tell a family member about what they made. And while they do it, if they do it quickly, you move on to a next step and say, test it out. Let's test it out and see how it worked. Is it working the way that you wanted it to? How could you improve it? Right? And these are the question prompts you give them to make them think more and more as a designer. You could give them a cup and say, go fill the cup with water. How does this work and why does this cup work? Then you can say, give it a grade between 1 to 5. 1 is good, 5 is bad. Is this working? And you can give them another object and say, go fill this with water. 1 through 5, go ahead and grade it. And they're thinking about the pieces. Why does this piece work better than that piece for this certain task? And you're putting them in that design phase, in a design mind. Everything we have has been designed. If it's not from nature, it's been designed, and it's very questionable that nature's been designed as well, right? Everything has a design to it. Another one is imagine it. Think of something that might make your day better. For everyone pictures it. Think of something, an object that might make your day better. And when you picture it, draw a diagram. Draw a diagram of whatever you're picturing that might make your day better. Maybe it's a cup of coffee. Maybe it's some nice tea and some fruit that we're going to have. Draw it. Practice diagramming it. And when you do that, you get into a geospatial element. You're moving it from maybe a 2D design, two-dimensional, to a 3D design as you start drawing and thinking about the pieces. You're thinking about the detail. And as you start drawing, you're actually designing because you're imagining how the different pieces work together intricately as you put them. So if you try to draw a piece of pineapple compared to drawing an entire pineapple, and then you start thinking about it, why is the pineapple drawn this way? Are you going to start off with the roots and the leaves on top and the base on the bottom? And then you start thinking about why is it like that? How is the water flowing? Where is it connecting to the roots? Where is it? All those pieces start going through you as you diagram and as you make it. After they've done it, if they still have time, you could say, go grab some materials and try to build a pineapple out of a cardboard box. Here's some paper. Try to make a pineapple out of paper. The next one is improve. So you can think of a game, any type of game. We'll actually talk about this tomorrow in the session on gaming. But you could say, how can we make this game better? Does it need more rules? Does it need less rules? Does it need more players? Just different ways of thinking about that. The last one is fix it. You can say, look around and we can use the cup again. You say, here's a cup. How can we make this a better cup? How can we make this website a better website? How can we make this app a better app? And just getting people to think about it, they'll start talking about the interface. They may start talking about how the data flows between something. And then go back, have them diagram it, have them diagram a new interface, and start thinking about the pieces and how they all relate to each other. So that's what we mean by making and by building a maker mindset amongst our students. So here's some types of makerspace projects. We don't have very much time, so I'll put links to these. One of them is a stop animation. Click on this. Actually, I'll put a link because we don't have very much time for it. But these are pieces of construction paper that have been cut out and drawn, and they build flowers. And I think, are you familiar with stop motion, where you take a picture and then you move an object, and then you take another picture, and then you take another picture, and you take another picture, and when you line them up, it's like a film, and they start moving together. So that's what this is. It's stop motion. Stop motion gets used pretty frequently. So it's stop motion. It encourages creativity, imagination. It allows children to bring their ideas in together. It's nice to make a stop motion video out of a book that they read. So they read the book, and they could build an alternative ending, or they could build a scene and make it. And you can use your smartphones to build this, which is really great. No question? Oh, no, okay. And this is what it might look like, where they build little sets, and you could put a camera on a selfie stick or any stick and just kind of hold it over it. These are little pieces of clay that they made for little characters that they use inside of their stop motion videos. And then you can see groups of people working on them together. So you get collaboration, you get planning, you get storyboarding, narrative, and design all mixed together. And all of these are pieces for STEM and STEAM: science, technology, engineering, math, and art. And when you put all of those together, it really helps to develop the complete child. Another thing we have are build challenges, where you challenge people to build something. You give them an hour, and you say, okay, we're gonna redesign this room to work for our conference, and you have 10 minutes. Here's a piece of paper and a pad. Get in a group of 5. Look around the room and try to redesign it for the conference. I can see a lot of you are already getting ideas. You're looking around and thinking, right? And that's what we want. We want to get the students active. Start thinking about design. Start thinking about how pieces move. And the next step would be to make it. So here's diagrams. Let's diagram it out. Let's take the 2D paper and make it into a 3D model now with clay or with Legos or something else. We're given a design challenge. They were given a couple of pieces of spaghetti, uncooked spaghetti, just a long noodle, and a marshmallow. And they had to basically see who could get the marshmallow to stick up the highest by using spaghetti to either make a pyramid and put it on top, or to put the spaghetti noodles together. And there's a lot of different ways that they tried to do that. One of the best books about makerspaces is called Design, Make, Play. So this book here is called Design, Make, Play, and it's an edited book, so there's several authors. And they all talk about different aspects of it. There's a chapter on facilitating, there's a chapter on building, there's a chapter on making for different ages. So you could see how they've got these noodles and tape, and they're basically trying to see who could stand these up the highest. So that's an idea of a design challenge, just getting them to think. But what's good is they collaborate, right? Because we know that all work is teamwork. Everything that we do, you're collaborating. So we have to learn how to collaborate, and our students have to learn how to work in a group. They have to learn how to play roles. They have to learn how to lead, but they also have to learn how to follow. And they have to learn how to collaborate. And these are all skills that we could teach them in the library. There's another design challenge where they're given these are pieces of cardboard that were actually cut on a laser cutter to make these shapes. So you could stick cardboard in, and then you have the laser cut these into shapes, and you can make puzzles out of them that can build up. So this team was asked to build a bridge. So they're making different ways of making a bridge. And there's other build challenges. Who could throw it, make an airplane, and who could throw it the furthest. So these are little airplane made out of cardboard, and there's little pieces there's coins that are taped to it to give it weight. There's a paper clip on the back to see if it can fly better. And this is something I use for adults in a room about your age. And people are just laughing and throwing their airplanes around and having a good time. I mean, people almost lost their eyeballs, but it's okay. Nobody died. And then, of course, the sketching becomes important, right? Drawing things out and the planning process of how are we going to build this. And here's some different kind of STEAM projects. So by STEAM, it's science, technology, engineering, art, and math all put together. So this is mathematical jewelry that some of the students made. So they took mathematical formulas, put them through the computer, and built the diagram, made it into 3D print, and then they sent it out to a metal shop and had them plated in gold or plated in silver, and they started selling these as a business. So they basically took mathematical formulas and made jewelry out of those. That's a spiral sunflower. These are laser burned and laser cut information graphics, like an infographic. So instead of just having it on a printed piece of paper, they made these out of the 3D printing. They burned those with the laser, all the words, and this is basically a chart, and you can see how it's a 3D chart and how effective that can be. This is another one for bubble tea, where they made little teas, and they're showing how popular they are based on how many bubbles they have in them. And they're using the laser printing and laser cutting for that as well. So in the last 2 minutes, I'm going to show you some quick makerspaces. This is a makerspace in elementary school. On the walls, they have tools. They have little pieces of Legos. These are 3D printers, and just empty chairs and desks so that students can sit around and work on things. They can plan, they can program, and then they can just walk up and grab pieces of either tools or materials out of those little bins to make things. This is an adult makerspace. They actually have liquor and beer and everything else. And they make beer and they make wine as part of their making. That's why these pumpkins are there. They're letting them rot because they're going to make a pumpkin wine. And they have all their little tools out. This is a makerspace at a college. You can see there's the sewing machine, which are always popular, robotics kits, virtual reality, 3D printing, and other pieces all put together in this type of makerspace. And this is another adult club where they're doing soldering and working with small hand tools to build those little mini computers. So this is actually hobbies that adults are doing now in the makerspaces as well. And this is a makerspace at a public library. So you can see the books, and they built this space inside of it so that, of course, the sewing machines, I'm telling you, the sewing machines are the most popular. And then they have the 3D printing, and these look like high school students are inside working, and everyone else is just working on the library.